Okay, sample problem 3.3. Write and balance the chemical equation for the aqueous reaction of barium hydroxide and perchloric acid to produce aqueous barium perchlorate and water. Now, one of the things that's difficult about this particular problem is that they're giving the names of materials instead of giving you the chemical formulas. And in this particular example, they picked some materials, or at least I should say they picked a couple of materials that are not particularly common. So you wouldn't be expected to know these chemical formulas. At least most people wouldn't expect you to. So what I'm going to do is I'm going to go ahead and give you the chemical formulas. So barium hydroxide, actually let's go through this. Barium is in group 2. Oops. Barium is in group 2, so that means it has a charge of +2. Hydroxide is a polyatomic ion, so it has a charge of -1. Okay? The group 2 metals, which would be beryllium, magnesium, calcium, strontium, and barium, they have charges of +2 as ions. The hydroxide ion is a polyatomic ion. So if you take a look at their charges, the barium has twice the charge of hydroxide. So if you're going to write a chemical formula, we need 2 hydroxides for every barium. Right? Because if each of the hydroxides is -1, 2 of them would give you -2, and that would balance the charge of the barium, which is +2. That's the driving force behind the formation of ionic compounds, is that the charges of the positive ions, the cations, is equal to the charge of the negative ions, the anions. So there's our first reactant. The second reactant is called perchloric acid. That's HClO4. Okay, so there's our second reactant. Now, what does it tell us that it forms? It tells us that it forms barium perchlorate. Now, in order to figure out what the perchlorate ion is, acids can be thought of as an H plus combined with an anion. So H plus ClO4 minus. Almost like thinking of it as a ionic compound. Okay? Acids are generally thought of as molecular compounds, but in a sense, they have something in common with ionic compounds. The H is a plus and the nonmetal is a negative. Okay? So there's our perchloric acid. So that means that when we write out the chemical formula for barium perchlorate, we have barium, which has a charge of +2, and then we have perchlorate, which has a charge of -1, which means we need 2 of the perchlorates, just like we needed 2 of the hydroxides. So we write that with rounded parentheses, and then you put a 2 to the right of that as a subscript. So 2 perchlorates for every 1 barium. Water, of course, we know what the chemical formula of water is. So now we can write the equation. So the first, we write the equation. So barium hydroxide, it says aqueous, by the way. So barium hydroxide, that just means that it's dissolved in water, is reacting with perchloric acid. Again, these are aqueous solutions. So that means everything's dissolved in water. So you get barium perchlorate. And I've run out of room here, plus water. Okay? Water generally we write as a liquid unless we're given information otherwise. Okay? So there's our equation. That's the chemical equation. In a sense, that's probably the hardest part of this problem. Not actually balancing it, but writing the equation. They didn't give you the simplest chemicals to react here. Okay? So let's come back and we're going to do the balancing now. So let me write this a little bit smaller. I'm going to go ahead and leave the states of matter out just so that we have room in this limited space here. There we go. Okay. Okay, so how are we going to balance this one? Now, when you're dealing with polyatomic ions, it's not a bad idea to balance the polyatomic ions together. Meaning, instead of doing oxygen separate from hydrogen or chlorine separate from oxygen, do them as a group. So you can think about barium hydroxide as having one barium, but having two hydroxides. You can think of the perchloric acid as having one hydrogen and one perchlorate. Barium, 1, perchlorate, 2. And then it's not a bad idea to think of water as H plus OH minus. Sometimes people will think of it that way. Okay, so that makes it a little easier to balance. I'm going to start on the left side with barium. There's one barium on the left side, there's one on the right, so it's already balanced. There's two hydroxides on the left, but there's only one hydroxide on the right. So let's put a 2 in front of it. Okay, so that gives us 2 H pluses and 2 OH minuses. So let's come over here. There's one H plus there, but there's 2 H pluses now, right? Because I put that 2 in front of the water, so that gives us 2 H pluses and 2 H minuses. So let's put a 2 in front of that. So that gives us 2 H pluses. But it also gives us 2 perchlorates. So there's also 2 perchlorates. So now there's 2 of each of those. And there's now 2 of each of these. So if you think about it, there's one barium, 2 hydroxides, 2 hydroxides, 2 hydrogen ions, 2 hydrogen ions, 2 perchlorates, 2 perchlorates. It's now balanced. You can also do it separately by each element. You could balance the barium first, and then I would recommend doing chlorine next, because chlorine appears only in one reactant and one product. And then you could do hydrogen and oxygen. So if you were going to do this by element, I would recommend doing the metal first, the barium, then the chlorine, then the hydrogen, and then the oxygen, and you'll get the same answer. Okay.